Welcome students, this is Professor Pushkar Shinde. Today we will be discussing Virtual 86 mode, a topic in the Unit 5 of Microprocessor. So we will be discussing upon various concepts of Virtual 8086 mode in 80386. Basically the Virtual 8086 mode is useful for executing 8086 programs. So for backward compatibility, to execute 8086 programs on 80386DX, we have the virtual 8086 mode, or it is also called as a virtual 86 mode. So speaking about the virtual 8086 mode, basically the 80386 supports execution of one or more 8086, 8088, 80186 or 80188 programs in an 80386 protected mode environment. So basically virtual 8086 mode works in the protected mode of 80386 and it is used to support execution of not only 8086 but 8088, 80186, 80188, these microprocessors programs are also supported in the virtual 8086 mode. So all these previous microprocessor programs can be executed in the virtual 8086 mode. The 8086 program runs in this environment as a part of a virtual 8086 task. So basically the 8086 program runs as a virtual 8086 task. So it uses the multitasking feature of the protected mode of 80386 to execute the 8086 program. The V86 tasks take advantage of the hardware support of multitasking offered by the protected mode. So basically the multitasking feature is used by the virtual 86 task. Not only there can be multiple virtual 86 tasks, each one executing an 8086 program, but virtual 86 tasks can be multi-programmed with other 80386 tasks. So basically each 8086 program will have a virtual 86 task for it to execute that program, and this virtual 86 tasks can also execute with other 80386 tasks because all of this is happening in the protected mode which supports multitasking. The purpose of a virtual 86 task is to form a virtual machine with which to execute an 8086 program. Basically the virtual 86 task, it uses a virtual machine in the 80386 to execute the 8086 program. The virtual machine that is used in the virtual 8086 mode is not only a part of 80386 hardware but it also uses system software. So the virtual machine uses both 80386 hardware and system software. Thus the emulation of an 8086 program is result of cooperation between hardware and software. That means 8086 program will be executed on a virtual 8086 machine. Emulation of the 8086 is done by the virtual machine. It forms a virtual processor in the 80386. The hardware provides a virtual set of registers via the TSS. So the virtual machine uses the hardware which provides a virtual set of registers, and the registers are stored in the TSS. You all know 8086 is a 16-bit processor. So it has 16-bit registers AX, BX, CX, DX and so on. So these registers are stored as a virtual set of registers in the TSS. A virtual memory space, the first megabyte of the linear address space of the task, is also provided by the hardware. So virtual memory space is provided, it is 1 MB. You know, the 8086 has a address space of 1 MB, as it has a 20-bit address bus, so 2 raised to 20 is 1 MB. So the virtual 8086 mode also supports 1 MB of address space for every 8086 program, and directly executes all instructions that deal with these registers and with this address space. So all the instructions associated with the program will be executed by the hardware using the TSS and the virtual machine that is provided for the program. The software controls the external interfaces of the virtual machine. So the software controls the external interfaces of the virtual machine. Like the program may read from the user, display to the screen. So all these external interfaces are handled by the software for the virtual machine. Now the executing the 8086 code. Basically the processor executes in Virtual86 mode when the VM virtual machine bit in the E flag register is set. So processor executes in Virtual86 mode when the VM bit of the E flag register is set. Only then the Virtual86 mode will be enabled. So to enable the Virtual86 mode, VM bit in the E flag register has to be set. Always remember, it can be set only in the protected mode. So you cannot switch to Virtual86 mode from directly the real mode. The 80386 has to be in the protected mode, and then by setting the VM bit you can switch to Virtual86 mode. Processor tests the flag. Processor tests this flag under two general conditions. That is, the VM flag is tested under two general conditions. When loading segment registers to know whether to use 8086 style address formation. It is when the segment registers are loaded and it is checked whether 8086 style address formation is to be done. That time the VM flag gets checked. And when decoding instructions to determine which instructions are sensitive to IOPL. So while decoding the instruction also the VM flag gets checked. So while loading the segment registers, the VM flag gets checked, and while decoding instructions the VM flag gets checked, and it has to be 1 to enter into virtual 8086. Registers and instructions in the virtual 8086 mode. So all the registers defined by the 8086 are available in the virtual 86 mode. So that is the 16-bit registers AX, BX, CX, DX, SI, DI, SP, BP. So all those 16-bit registers of 8086 are available in the virtual 86 mode. Plus the new registers introduced by the 80386 like FS, GS, debug registers, control registers and test registers. They are also available in virtual 8086 mode. New instructions that explicitly operate on the segment registers FS and GS are available, and the new segment override prefixes can be used to cause instructions to utilize FS and GS for address calculations. So basically FS and GS is also available in virtual 8086 mode along with the other segment registers which are also available in 8086 like CS, DS, SS, ES. So basic segment registers plus FS and GS, they are also available. FS and GS are the new segment registers introduced in 80386. They are also available in virtual 8086 mode. All the instructions of 8086 are supported in the virtual 8086 mode. So registers of 8086 and instructions of 8086 are available in the virtual 8086 mode, plus the additional registers and instructions of 80386 are also available in virtual 8086 mode. So as mentioned earlier, 8086 programs running in virtual 86 mode can have access to new instructions that are available in 80186, 80188, 80286 and 80386. So all the new instructions are also available in virtual 86 mode, though it is running a 8086 program, but it can use the instructions of the higher end microprocessors. So the next concept is how is the address translation done in the virtual 86 mode. So the linear address formation in the virtual 8086 mode works in the same way as the address translation is done in 8086. So it uses the concepts that are used by 8086 for doing the address translation. So what happens is that, 8086 is a 20-bit it has a 20-bit address bus. So it uses address of 20-bit in 8086. So 80386 in virtual 86 mode also uses 20-bit address, as it is emulating the 8086 in that mode. So what happens is that, segment registers are 16-bit. So the segment registers in 8086 store the base address of segment. So the same thing happens in the virtual 8086 mode. The 16-bit segment register has to give a linear address of 20-bit. So for converting a 16-bit address to 20-bit address, the base address is shifted left by 4 digits, or rather 4 bits, not 4 digits, 4 bits. So you have a 20-bit base address by shifting left by 4 bits. So the 16-bit address is converted to a 20-bit base address. In that, the offset is added. So offset is added with 4 bits on the left, whereas the base address 4 bits are added on the right. So 20-bit base address and 20-bit offset address are added to each other to get the linear address. So base address is 20-bit, offset is 20-bit. Base address is stored in the segment registers. So you have, for code segment, CS will be the segment register. The base address will be stored. For data segment, DS will be the segment register used for storing the base address. Its value is added with 4 bits to the right. And offset for code segment will be IP rather, 16-bit IP. For data segment it will be SI. For extra segment it will be DI. So the offset register is also appended by left 4 bits and the base address is appended by right 4 bits, and you get the 20-bit linear address in virtual 8086 mode. Because of possibility of a carry, the resulting linear address may contain 21 significant bits. So range of address will be from 0 to 10FFEFH, that is 1 MB plus approximately 64 kilobytes, because of the carry generated during the address calculation by adding the base address and the offset. V86 star generates 32-bit linear address, while an 8086 program can only utilize the lower order 21 bits of a linear address, because 8086 uses a 20-bit address. So out of the 32 bits, only 21 bits will be used for the linear address in a virtual 86 mode. This linear address can be mapped via page table to any 32-bit physical address, because 80386 physical address is 32-bit. So the 21 bits out of that are used from the 32 bits, and you are getting the physical address